Lava, lava, lava everywhere. Oh my god, it's lava. Let's get some over here. Yeah, that's the lava that I like. You hot, lava. You hot. Yeah, drip down that mountain just like that. Oh, I'm sorry. Didn't see you there. I was just getting all up into the development of this thing here. So, I've got the water simulation and I've got some lava simulation. And so, what I want to do is use both of them to, oof, that's crazy, to make it so that the planet can change over time, go from kind of one state to another. So to do that, I want to start off the planet with a lot of heat. I was thinking about maybe having some concept of core heat, but for now I think I'm just going to make the surface really hot, and then no, I should probably have some concept of the core heat just to trigger basically volcanoes. Like the hotter it is, the more volcanoes there are erupting, and then have some events to actually start triggering lava, but also to have water evaporation. And I think I'm going to do that part before I actually start triggering volcanoes. So basically I want to make it so that there's a water temperature and there's a land temperature, and if the land temperature is above the boiling temperature of the water, based on how much above the boiling point of the water is, the water will start evaporating. Eventually I would make it so that even if water is below boiling point, there's a certain function of how much evaporates, and at some point I'll probably actually look up some actual scientific stuff on like how water evaporates based on temperature and air pressure and relative humidity. But for now I'm just going to stick with some boiling point stuff, and then once the water's in the air, if the air temperature drops below the dew point of the water, which for now we'll just consider it to be the boiling point, I would say it's 212 degrees at sea level, that it'll start raining, and you won't see any rain per se yet, but you should see like the water start to grow. So what I'm gonna do is get cracking actually on the water evaporation stuff. First, what I'm going to do is start off the planet being really hot, and this is going to be really simple because I have some code that just sort of initializes the planet to a certain state. So I have right here, so height, temperature, water, the amount of water sitting on the land, and vegetation, which I'm not using yet. So the second number is the temperature, and I'm going to set it to, well, what would be funny if I actually just set it really high, and then I bet I'll have a green planet, like 2,000 degrees, because it'll be black. Well, I don't. Oh, there! Look at that, crazy. So, I wonder if I set it to something even crazier, like 20,000 degrees, what it'll look like. You should have like the lava under the water, and then the water sort of filtering that light that lets some green and blue but no red through. So in the lava there's not really much blue, and the water doesn't let much red through, so there's only really green left, and that's why it's looking green. And wow, it looks almost like the moon. Look at that. Okay, but I don't want it actually that hot yet. For testing, I'm just going to put it to like 500 degrees. And so then I need to go to my simulation, and I need to transfer water from the sea to the air. Now ideally I want this to be like a kind of physically accurate thing, where there's a certain amount of water mass leads to a certain amount of, well actually I'm calculating there's this much mass of water transferring from the water to the air, and then at some point I'll have to do a calculation on like, well, how much water can the air support, at a certain temperature, basically, before it starts to rain. But basically, since it's really hot, it shouldn't rain because the air will be so hot. But I might have to look up some numbers for like relative humidity stuff. Okay, so I need to go to my simulation code, which runs in this, I call it Planet Simulation Shader because it runs actually on the graphics card. And so compute diffusion, compute surface and air heating, and so I'm going to make a new function called like compute, like water evaporation and condensation, or water phase, maybe, because like phase is like the state of matter, like liquid, solid, or air, vapor, gas. So I'm going to just kind of use this as like a template for how to make it look, and then I'm going to say compute water phase changes. Once again, I'm going to be lazy and just it's always dangerous to do copy and paste, generally speaking, but this is a pretty safe one. I call it computer water phase changes. Okay, so I've got a space carved out for that now, and I need to actually do something. So the land temperature, I need to take a look at that value. And just to make sure I didn't jack anything up, sometimes I come back to Unity just to trigger it to process what I did and make sure there's no errors. And no matching function. I just put it right here. That's weird. And let me try again. No matching 6. Oh, because the vertex, I don't need the vertex ID. Okay, so now everything should just be the same as it was before, okay? I always like to kind of do a little sanity check as I make changes to make sure I didn't mess anything up along the way. Okay, so at some point I'm just gonna put in some semi-hacky numbers in here just to get something to happen. At some point I want to go back and reevaluate and make sure like I have like good physical conversions between different types of things and it all makes sense. Because I want the simulation eventually like be able to simulate what the Earth went through, even though it's not gonna be like there's a lot about it that's not physically accurate. It's just a game after all, but I think that's important to get it to be able to evolve over time. Okay. So evaporation rate equals land temperature minus boiling point times I'm gonna make it like a parameter right now called evaporation factor. Eventually this will be probably something more physically derived. I'm just gonna have like a number that I pick with a little slider. And so the evaporation rate can also be, if it's negative, it'll be like a condensation rate, which is basically raining. Land temperature. I want to be able to take water either out of the air or into the water. So I want to have to do. I like to a little like condition here, like to decide if am I taking air out of the water out of the air or out of the ocean, basically. Rate is going to be 0. Actually, that's interesting, because not exactly that simple, because the evaporation rate is going to depend on the temperature of the body of the water, which I'm sort of inferring from the temperature of the land. But then I have a separate air temperature, and that's going to actually determine the rain coming down. So this will be only evaporation that I'm doing here for the time being. And flow evaporated mass. I have to kind of bound how much evaporation I'm going to say, because it can't be less than 0, and it can't be more than the amount of water that's actually there. So I have this thing called clamp, which is like a weird programming term. It just means like put a lower and an upper bound on it. And so I'm going to take that value. The lower bound is 0, and the upper bound is like how much water do we actually have? I believe it's this thing. Yeah, it's the land water. And then I'm just going to subtract that out of what's in the land and put that into the air. And then the air has water too. So what I'm going to do is this is basically just saving the value back out to these giant, I call them buffers of data that exist in memory to store all this data for every single point on the planet. Equals land water. And then the air also has some data that stores how much water it has, and that's in that thing, pretty sure. Yeah. So that's all pretty simple. So that's evaporation, and then I'm gonna go ahead and do some cheap version of condensation, aka rain as well. Gotta make it rain. Gotta make it rain. So let's make it rain. So float air temperature equals air profs 1.y. And that's important because the temperature affects the condensation point, the dew point, essentially. So I'm gonna just Google really quickly dew point calculation. The internet is fantastic. Alright, so relative humidity. Let me see here. Excuse me while I get a little mathy for a second. Highest possible temperature at which water vapor can condense to form dew. Yep. Actually, what I really want to calculate is this maximum absolute humidity, like how much moisture can the air hold. So the dew point is calculated, the temperature, what is this alpha? Some logarithm involved. I don't want to get that fancy just yet. I'll look at this later when I'm off screen to really process it. But it looks like that's really more complicated than I thought. But to make it simple for myself, Let me look up relative humidity. Wikipedia knows all. Ratio of the partial pressure of water vapor in the mixture to the equilibrium vapor pressure of water. So what are these variables here? Absolute vapor pressure. So I'll just consider that to be constant. The temperature equals. What is P? Absolute vapor pressure. So P equals. So it's something plus something over the temperature. And it's a log of it. That's too complicated for right now. I'm just going to make it like a simple linear proportional thing. So I want to say flow max air water equals the temperature of the air times some constants, which I don't really know what a good value will be. But given that I'm doing right now, my temperatures are all in it's technically degrees Kelvin, but it's basically like degrees Celsius. Actually, no, yeah, so that's a good point. That's a Fahrenheit number. Kelvin, absolute zero. Actually, absolute zero. I didn't type that right, but Google knows what I'm trying to look for. Celsius is 273, so I want 373. So that's the boiling point in a certain type of way of measuring temperature. But the way I'm representing water mass is it's like one is like in 1,000 feet or something. So I'm gonna multiply this by something really small. And I'm looking for condensation. So I want it like a raining speed. And basically, if there's more air in the water than it can hold, it should fall. But more, like by a certain amount, I think. Because like there's gonna be like just see through some water vapor in the air, and then you have clouds, which is some condensation, and then eventually the clouds rain. So let me do this. Let me do like relative humidity equals. Okay, so now I have that. So if relative humidity is greater than, I don't know, let's say 1.1, something like that. Make it rain. I have to make it something called make it rain now. I'm not gonna do it. I'm not that bad. So I need surface water. Actually, what I'm gonna do is just say float rain amount equals I guess it is kind of a trigger. Now, how do I want to make it? I'm thinking about how rain works, how like it hits a certain threshold and then it keeps raining. And you don't want to stop raining once you just drop back down to that threshold. You want to like keep raining a little bit below. But I'm not sure if I have enough like information here to really like a place to store the fact that it's raining. So I might have to make a new place or figure something out, but if the air keeps cooling, it should be good enough, even if I use just that one threshold. Actually, and what I can do to make this a little easier is just say if there's more water in the air, actually, like how much water do I have more than I can support? So I'm gonna get that water out of the air. I'm gonna put it back in the sea. Which is this guy. And then I didn't ever define this, so I need to put that in there. And so this is going to be some number. It could be like 1,000 or something. Which is probably fine. How rapid a boil? I mean, if it's really hot, the boil is going to be super rapid. But it should be so that... I should transfer some... Technically, I should transfer some heat with it as well. I'll do that later, though. But I think this needs to be a pretty low number. And I think that's about it. So my planet seems the same as before. What is my temperature at? Planet. Yep, surface properties 500. Okay, so it's not hot enough to be lava, but it should be hot enough to boil the air if I actually give it, boil the oceans, if I actually give it some heat. So, this is making me think I might need to have more data in my simulation, like store the water temperature separately from the land temperature, for example. So it was my planet simulator. It's got its shader for the simulation. And I need to actually set that value, so. Simulator! Come here, simulator! I'm not going to put a range limiter on it yet, because I don't really know exactly where that should be. But. Times delta time is a good point. So. So right now I've got my oceans, they're all liquidy. And if I make the evaporation... Did I say it's going to be 1? Maybe I did. Yes, I did. Okay, so technically, I think at this point stuff should be evaporating, but it's not. So, what happens if I just do this as a test to say, yep, this evaporates some water? Nothing happens. So I'm just going to do some cleanup here. Land water. And air props 1.y equals air water. Okay, so let's make this even simpler. Let's say that the evaporated mass equals 0.01. What if it's like the amount of land water? That should all disappear instantly, but it's not going to because gremlins. So land water should be set to 0. Let me make sure that this isn't, the rain part isn't messing with anything. It's like it's not even running. What if I do something crazy? That worked. That should also make the water disappear. It did. Okay, so what? Oh, stupid, I'm adding and removing it. This is supposed to be air water. Okay. Now it's going to disappear. Bam. Okay, now we're getting somewhere. Now I should see it just kind of shrink over time. And when I set this stuff up, like there weren't large numbers for the water, right? 1.2. So, what is the problem here? Why is that not doing anything? Land water minus equals air water plus equals it. Oh, it's not running. That's why. Oh god. Okay, there's that. Okay. Bueno. So if I set evaporation factor to 0, I should have all my water, and then I'll set it to like 0.001. And I think, is it slowly changing? It's hard to tell. Maybe I get 10 times higher. So what I should be seeing if it's shrinking, oh, did it move? It's that, yeah, it should be moving in to the left of my mouse cursor there, and the water color should actually be changing to be more like the land as it shrinks, but it's not shrinking. Let's just try this. Okay, so that's shrinking, so something's off with the temperature calculation. Yeah, no problem, I understand that. Okay, so that did good. So land temperature should be higher than the boiling point unless it's cooling off so quickly because it's transferring the air to the heat or to space. So let me turn off space, like sending heat out to space and sending it to the air, just as a test. Okay. Yeah, it just cooled off too quickly. So what would be cool is if I get it so that it's really hot, all the air evaporates, and eventually it cools, and then it comes back. Which should happen if I re-enable this part. I want to make evaporation factor point to make it nice and fast so I can see it happen. For the actual game, I'm going to make it much lower because it's, things are supposed to change slowly over time and eventually you check back in on it. So right now I'm setting it to 500 degrees. Let's set it to like 3000 degrees and see what happens. I'm going to start off with evaporation factor off. So it's so hot, it's actually kind of like lava. And then 01. Wow, that was fast. I also think that I didn't turn this stuff back on. So if I wait a while and then evaporation factor kind of low. So I'm trying to see. Yeah, so it did shrink, so it just evaporated like immediately basically. Which is, I guess, what pretty close to what you'd expect to happen. Okay, there, it shrunk away. Now if I turn on rain, ooh, that was fast. So let's say, what kind of numbers do I want to pick here? The air temperature is 1,000. Maybe let's do this. Try this one. So the water came back. That's cool. So that's my hot piece of lava land that I made rise up. And then the air temperature. Wait, did it evaporate? I think it canceled out because it cooled too quickly. See this, to make it physically accurate, like there's a way to tie the evaporation part to the raining part that makes sense, but I'm not really tying them together. So if I make it a really high number, it should hold basically an unlimited amount of water. And then it rained back. I'm going to pick the number that made it do so. So, if the ocean's boiled, I wonder how much water the atmosphere could actually hold. I mean, I guess as long as it's above the boiling point, there's an unlimited amount. Then the pressure increases and there's like this weird balancing act, but I need to start getting some like good like fundamental basics of real world units of like mass and temperature and all that, but I'm kind of just fudging it right now. So then all the water went away, and then the earth cools, and eventually maybe it'll rain. Except that is a lot, because like the air temperature is still going to be fairly high, and the maximum amount of water should be 1.2 is how much water there is per unit. So let me do some quick math here. So let's say like 200 degrees, it can hold almost no water. Or should I say this? If it's above the boiling point, if air temperature is greater than boiling point, max air water equals, and essentially an unlimited amount. Otherwise, just some kind of linear equation like max air water equals air temperature divided by boiling point times, like, sure, 1, why not? So when it drops below the boiling point, there's going to be 1.2 units of water in the air, and there's going to drop, and the max is going to be 1, so it's immediately going to deposit 0.2, and then it's going to grow. That's what I should see. Weird is it's like fighting itself, going back and forth, but it shouldn't do anything until the air temperature drops below a certain point. Alright, so if I put this here, it's telling me the air temperature is going below the boiling point pretty rapidly. Which is really surprising. If I set it to not release any heat outside. And then if I make it where it can slowly get rid of some heat. Wait, this is... Oh, it's still doing it. What the hell? That's confusing. So all the water evaporates. I make it really hot. Oh, that's right. No, I didn't even make any heat go out to space. So what the heck? Should be 3,000 degrees. The surface here, I'm going to output the temperature just as a check. So the temperature is that one. So this should be black. Weird that it's not totally black. And then this, so it's greater than 200. What is the boiling point? 373. So it says it's greater than, it's hotter than the boiling point. It's quite hot. And you can see it's, I don't know why only half the planet is that hot. Oh, maybe because of the sun heating. Okay, so it's a pretty hot planet, so it shouldn't, nothing should be raining. What is the stupid mistake I'm making? What is the air temperature? I'm using the air temperature, maybe, but I'm looking at the land temperature. So the air is cold because I'm not transferring any heat to the air. That makes sense. I should adjust the air temperature based on how much water is going in there. Let me go ahead and do that. So I know how much mass there is in the air in total, so I should be able to update its temperature. So the whole total heat heat transfer equals the mass times the temperature of the mass. times the land temperature is what I'm using to represent the water temperature. And we'll call it evap for evaporation heat transfer. I have some number somewhere that I use to represent the mass of land, 10, which is just like a hack number that I need to replace at some point, but whatever. So pretty soon I'm gonna get the simulation working. It's gonna be really cool. The oceans will boil and the skies will rain blood. Well, maybe not blood, but something. And air temperature. Load air temp. Equals air props 1 to x. That's where I get that temperature. That's where it's stored. Air temp is gonna plus equal the heat divided the new air mass. I need the new air mass. Equals. So, how much mass do we have here? I initialize this stuff. I need to go ahead and put. Oh, there's some mass. Look at that. Relative proportions. I need to do some research on like how much mass is actually in the Earth's atmosphere. Which actually I guess is 14.7 per pounds per square inch is what it is. Which is not much at all. Which is like the amount of water, and I think 30 feet of water corresponds to the same amount as... Wow, scuba diving came in handy to make this fucking planet game. Because I know that when you go diving, you go down 30 feet, and that's like one additional atmosphere of pressure, and the pressure comes from the mass. So, well, bada bing, bada boom. That's a good representation of how much air mass there is. Haha. This shit's gonna get physical. Equals. So what I should do then is, if I want to give it defaults that are like Earth, I should multiply this stuff times like, well, how deep is the average? What's the average depth of the ocean? But then how much of the Earth is ocean? Okay, so it's 3,688. That's how many meters. And percentage of Earth covered by ocean is 71%. So I'm gonna write these calculations. Ocean depth equals flood Earth ocean coverage equals 0.71. So that's going to be the total mass in the Earth's oceans. So the air column mass equals equivalent of depth for water depth for 1 atmosphere. 33.8 feet. Oh, look at that, which is like a meter. 10.3 meters. Sorry I'm looking at code so much. I'll have to show some more lava in a second. This is taking a little longer than I hoped it would. Divided by Earth. Equivalent water depth for 1 ATM equals 10.3 F. So that's how much air there is per column. And is that all there really is to it? I guess I don't really need that Earth's ocean coverage, do I? And theoretically, I would. My Earth is 100% covered, so the ratios are a little different, but I don't need to make it exactly like theirs. Oh, but then I'm saying point. That's it. So 0.4 is actually that's if I wanted to compare it to like 1, how many times that? Because I'm saying 0.2 is like kind of like the average depth of the ocean on my little planet. Eventually I'm going to make it more like real numbers, but for now. So these are going to end up being pretty small numbers. So now back to the thing, I have to do the total air mass. For air non-water air mass equals air props 2 CO2 is 3. But air mass equals plus the water mass. So that's like 100% even mixing of the water into the air, which wouldn't really happen, but it should be good enough. Air props 1 to x equals air temp. And then surf props 1 to y equals land temp. Okay, so I took heat out of the air, land, I put it in the air, but now I need to do the same thing here eventually. That's why land water. Oh, I need a semicolon. Stupid programming errors. Evap heat. What about it? Oh, what did I call it? Evap heat transfer. Am I still looking at the air temperature here? Surface shader. Debug output. How hot is the air? How is it hotter than 10,000? What did I mess up in my calculations? Oh, because I have all that mass. No. Let's say 0. Somehow I'm like doing the physically impossible. And if you've joined the chat, feel free to say hi in the chat, and so I know you're there, and maybe I'll show you some cool lava stuff I've been working on. Because right now I'm in the middle of debugging like a tricky math thing that's not as crazy, but it'll be cool once it's working. So all that air is going to be like almost nothing. Right? I wonder how much that actually is. I should take a look. Take a look. Yeah, take a look in a book. A reading rainbow. .0005. So it's like 1 out of 1,000. Yeah, I mean this is basically 1 out of 1,000, and then 0.2, 1 out of 5,000. So the air mass is going to dominate. So I have the evaporated mass times the land temperature. So mass times temperature is heat. Let me move this down here. It's now water, air mass plus air water. Air water. So evap heat transfer is the mass times the land temp divided by mass. So it should basically really quickly rise to equal the land temperature, because the existing air mass is almost nothing, so all that hot water is going to come up and just in the atmosphere, and that's going to be the atmosphere. So it should eventually rise to about 3,000 degrees. I think that's what I started the land off at. Yeah. I set the evaporation factor to 0. Then should have a nice cool plant. I don't know why it's that color. Oh, what is this minus 10,000? Oh, that's what I did, yeah. Okay, it was going negative. It was going negative on the campaign trail. Why does it happen so immediately? Oh, one. So it's immediately going not to 3,000 but over 3,000, which isn't making any sense to me. Oh, it's that sun heating. Gonna get rid of that shit. Get rid of that sun heating. Get out of here, sun. Nobody needs you. So now if I start evaporating, I'm gonna do divide instead. What the heck? It's going crazy. Oh yeah, why am I doing plus equals? It's not plus. Oh yeah, it's the heat transfer. Something about that. Do one chunk of mass. It's got this temperature and this heat. Now, okay, now that. Then I do another chunk. 1 unit of heat. 1 unit of mass. So then I say the temp is heat over mass. So let's say it's 1. And then I do a little math here, sorry. Add 1 more unit, so now I have maybe I should do like the original NMS times heat plus. Yeah, it has to grow because. Yeah, that's not right. If I mix two things of the same heat, it shouldn't get hotter, but that's what's happening. If I mix two things together, I don't add their temperatures, I average their temperatures. So am I even doing the land temperature loss correctly? Yeah, I think the loss is correct. I have a certain amount of mass. And my total heat is mass times T equals heat minus heat over mass equals T minus H over M. Okay, so the way I'm calculating the loss of temperature from the land is okay, but the other one, I have M1 T1 plus M2 T2 over M1 plus M2. And what I'm doing is T1 plus T2 over M2 equals H. Oh no. Plus H. H1 T2 This is H2. Yeah, that's not right at all. So, need to get the original mass. Where's my air mass? Air mass equals that's air water, so that's the original values right there. Air temp equals air mass plus evaporated water, evaporated mass. Or divided by. Actually, no, that's air mass times air temp. Oh, let's move that up here. I already have air temp. Plus evaporated heat. Mass times temperature is heat, so where's my evaporated heat? Divided by air mass plus the evaporated mass. And now I add the water to the air mass. Okay, I think I've fixed it. I think I've got it. Air, water, air, water, air, water. Air, water. It's air and water. It's all the elements. Land, air, water. Land, air, water. Lava. We are the Power Rangers. Lava was a Power Ranger, right? Or one of the Captain Planet people. It's called Captain Planet, but it was really all those kids that did the work. What the hell? He's over there taking all the credit. He's probably a pedophile. You heard it here first. Captain Planet was a pedophile. Air, water, air temperature, air mass. Wait, what is... I don't even think I use this air mass anymore, but it'll just get compiled out if I don't need it. So now I should see the air slowly heat up. But it's still fast AF, what the fuck? If I take out this line, it'll be fine, right? That's air heat. Fuck. No, wait. Air mass times air temp. If I do this, what happens? Should stay cold. Should actually get colder, if possible. So evap heat transfer is evaporated mass times land temp. You got that right. Why the hell is that not working? If the air gets crazy super hot, it's never gonna rain, and I gotta make it rain. Coding hell, well, yeah, a little bit. Well, that's normal. This is taking... I must be tired. I didn't get a whole lot of sleep because there's something stupid. Like, this isn't that complicated. Damn straight I want to make it rain. Land temperature. Just for like testing purposes. Like show how much heat is actually being transferred. So it should be like 3,000. Oh no, but nothing. Got 3,000 times some mass divided by that mass should be 2,000. That's more like it. Actually, if I set the 1, it shouldn't quite... I should see something. Wait, is nothing evaporating? Why is it not shrinking? No, I'm confused. Okay. It's so sudden though. Bam. Oh, it's because it's the, oh yeah, that's right. It's based on the temperature difference. So like, the air temp. I guess it makes sense. The air temp would pretty much immediately go to 3,000, but it shouldn't go any higher because the existing air mass is almost nothing. What the heck is the temperature? Well, that's good. So it's getting over 2,000 degrees. It should be just barely under 3, but it's not even making it to 25. Oh, minus the boiling point. That's part of it. Oh, that's the evaporation rate. That shouldn't really affect the temperature too much. Evaporation rate. So I have an amount of water that's evaporated. And that's possible. Let's just do a quick stupid test. Okay, so that got hot at that speed. But not hot enough. Not hot enough. Or did it? Weird. Like the mass of like the oxygen and everything that's not water is like 1,000 less than of what the water is. So that should be almost nothing. What happens if I say non-water air mass? Is 0. So that start first time, that'd be 0. That'd be 0. So it'd be that P is transfer time divided by what we should used to be the land temperature next time around. I saw. Well, when I restarted the stream, they weren't there. Are you saying they're gone again? Oh, I wonder. It must be somewhere in Streamlabs. It's overriding it. I'll have to fix that next time. In Resident Evil. That's funny. Let me see if I can adjust it from the third party thing. Weird. That's annoying. I really like the restream, but if it keeps messing with things, maybe I'll stop using it. I don't know. Awesome. Thanks for the followers. Woo-hoo. Alright. I have to decide if I'm going to keep... Yeah, I will do that. I'm not logged into Twitch on my other computer. I don't... I guess I could... Don't really want to do it on this one. The stream, I think I'm going to end in like 12 minutes anyway, but I'll have that ready next time to be on top of that. Yeah, thanks, man. Alright, why didn't anything evaporate? What the hell? What the fuck? Heat times evaporated mass. Is the land not the temperature I thought it was? Whoa, and then it disappears? Where does it go? Oh, the Earth is losing heat somehow. I am doing the land temperature wrong too. Boiling action is a heat losing action, but that's because it's the hottest particles that boil. So I don't think I need to adjust the land temperature at all, actually. Why did I think I had that right? Land temperature doesn't do anything. Technically it would be, yeah, water would be cooling off. Should then eventually make it back to the land, but I have that through my air and thing. Okay, so this I think is gonna work now. Good. Okay, not like that. Why is my planet not shrinking? Shrink, planet! Shrink, damn you! Maybe I commented something out? The crap. What in the crap it? Wait, why is it red there and dark when I start playing? So I'm not doing anything with land temp anymore. Why would land temp not be exactly... Just to make sure there's nothing else interfering, I want to disable this other code. Because something else is interfering. What is it? How's that doing anything? I thought all my numbers are 0 here. All my numbers are 0. Is it the love? No. Exchange. Should air mass be negative? What? Why is this stuff that I thought was disabled affecting anything? Anything! So it's these lines that are messing with my program. Yes, it is. That should be 0. Weird, it's like this number shows up as 0 here, but somehow it's not 0? What the hell's going on, Unity? I'm about ready to just start playing with some lava because, just because. Let me go play with some lava. My hot, hot planet. On my hot, hot planet, I'm going to place some lava. What a hot, hot planet. Wow, it looks purple when the ocean floor is all black. Interesting. So there's my crazy evil island. Now I'm gonna put some lava on it. Beginning to shape up, jeez. Whoa, look at it flow. Orinoco flow. Looking at that really makes, like, I have all these vertices that represent the planet, and then I can stretch them outward, but when it makes these get really stretched out, which I don't really like. Makes me wonder about maybe dividing it up somehow, but that's going to be tricky. But in the meantime, I can just make it not draw so tall. That helps a lot. Flow, my lava, flow. March forth to the seas! To the seas! Yeah, flow faster. Planet Painter. Let's get some shit going on. Whoa, I made that one funny looking. Whoop. I want to make that drain. You know, I'm gonna make a big pool. Big old pool. And then another big old pool. I'm gonna raise them all up. I'm gonna raise the roof. Whoa, that's high. And then I'm gonna try a little game that I call Make 'em Spill. Ooh, look at that, drained right out. But now I can come here. I can fill it back up. It slowly drains out. Slowly. Oh, I love this simulation. And then I can make it go down to the ocean. And that's slowly going bye. Okay. Well, that was a fun little diversion. Oh, it's 5 o'clock. Okay, I think I'm going to call it a day on the stream for now. I'm just stuck in this debugging stuff, and I don't think particularly fun to watch, and I can probably concentrate a little better anyway if I'm not on the stream. So thanks, Justin. Thanks, everybody else. I'll be back tomorrow with something a little better prepared to stream. Oh, yeah, one more thing. I was thinking about the name. I think for now, I was gonna say Pet Rock Simulator, but Galaxy Garden also sounds good. So, still deciding what I'm gonna. It's still not the final name that I'm gonna use. When the game's actually released. But in terms of for the pitches, Pet Planet Project. Yeah, one of the names that I had was Pet Planet. But I felt like maybe that sounded like a store for dog food. So I think just using the humor of Pet Rock Simulator. I have to Google around and see what results that gets, but would just get people's attention. So I'm leaning toward that one right now. Anyway, signing out. See you later.